Hello, my darlings. We are now looking at what is called the binomial distribution. All right, so we have conditions for a binomial setting, and this is when you're running an experiment, but there's 4 specific things that have to be true for it to be a binomial experiment. First, you have to have a fixed number of trials. So you flip 5 coins. You shoot the basket 30 times. You do something for a set number of times. And each trial, there's only 2 outcomes, success or failure. That doesn't necessarily mean there's just 2 possibilities. It just means some of the possibilities are a success, some of the possibilities are a failure. Like if I roll a die and I need to roll a 1 would be a success and it would have a probability of 1/6. Any other number would be a failure and it would have a probability of 5 out of 6. The trials are independent from each other, meaning if I flip 5 coins, how the first coin lands has nothing to do with how the second coin lands, which has nothing to do with how the third coin lands. So each of the trials are completely independent from each other. And the probability of success is the same for each trial. If I roll 5 die, the probability of getting a 1 on the first die is a 1 out of 6. The probability of getting a 1 on the second die is also a 1 out of 6. On the third die is also a 1 out of 6. So the probability of success stays the same. Okay, so binomial random variable, well, you're counting the number of successes observed in a binomial experiment. So if I rolled the 5 dice and I was looking for 1s, I got 1, I got 2 1s, I got no 1s. So we're just counting how many 1s did I end up seeing. So example 1, determine whether the random variables below have a binomial distribution. Justify your answer. So we roll a fair die 10 times and let x equal the number of 6s. Well, yes, there's 10 exact trials. It's either a 6 or not a 6. The probability of success is 1 out of 6. The probability of failure is 5 out of 6 every single time. And, how you rolled the first die has no effect on how you roll it the second time or the third time, so they're all independent. Okay, so B, shoot a basketball 20 times from various distances on the court. Let y equal the number of shots made. Well, no. Because of the various distances, the probability of success is not going to be the same every time. Depending on where you're standing on the court, you have a better chance or a worse chance of actually making the shot. Okay. So C, observe the next 100 cars that go by and let C equal the color. Well, no. There's more than 2 outcomes. They're also, we're not counting, we weren't told to look for a specific color. We weren't counting how many were red or how many were blue. So, this does not fit. There's more than 2 outcomes. Okay. D, deal cards from a shuffled deck and count the number until you get a red card. No, it's not a fixed number of trials. You might get the red card on the first one, or you might get black-red, or black-black-red, or black-black-black-red. So it's not a fixed number of trials, so it would definitely not be a binomial distribution. Okay?